A planet without a sun should be dead. No sunrise, no warmth, no seasons, no energy. Just a silent rock drifting through black space, freezing forever. That's the rule. Planets stay alive because stars feed them. The closer you are to a star, the more heat you get. The farther you go, the colder you become. That's why the outer worlds in our solar system are dim and frozen. Heat is a gift, and distance is the price. So if a planet has no star at all, it shouldn't have anything. No light, no atmosphere worth mentioning, no motion, no activity. It should be a corpse. But somewhere out there, the universe is hiding a different kind of world. A planet that doesn't orbit a star. A planet that has no sun. A planet that travels through interstellar space like a ghost. And yet, it may still be warm. It may still be active. It may still be glowing. Think about how wrong that is. A rogue planet, a planet that was ripped away from its solar system, should lose everything that makes it feel real. No star means no energy input. No energy means no surface life, no surface chemistry, no reason for anything to move. So, if a planet like that is still producing heat, then something is happening under the surface. Something that doesn't need sunlight. Something that doesn't care about distance. Because this kind of planet exists in the coldest environment possible. Not winter. Not deep space near a star. But the space between stars, where darkness is permanent and temperature is brutal. And yet, in that darkness, there are hints that some of these planets aren't frozen solid, that they might have enough internal energy to keep parts of themselves from dying, which forces a terrifying question. If a planet can survive without a sun, what else could survive? Most people imagined life as something that needs light, a blue sky, a warm surface, a world that looks like Earth. But the universe doesn't care about our imagination. It only cares about physics. If a planet can generate its own heat, trap it, recycle it, and hold it for long enough, then it can create conditions we never expected. Not on the surface. Under the surface, hidden. And when you realize that, the concept of a habitable zone starts to feel childish. Because the universe may have built life-friendly environments that never see daylight. Environments that don't orbit a star. Environments that drift in silence for millions of years, carrying their own energy like a secret. But how? How can a planet with no sun keep heat? How can it avoid turning into a frozen stone? How can it glow at all? The answer is not one thing. It's a stack of mechanisms, brutal, rare, and completely real. Some planets are born hot and cool down slowly. Some contain radioactive elements that keep releasing energy. Some might have thick atmospheres that trap heat like armor. Some might even have moons. And if they do, gravity can squeeze them from the inside like a machine. And that last part is where the story becomes dangerous. Because if a rogue planet has a moon, tidal heating can keep an interior warm, even in total darkness. It can keep an ocean liquid beneath ice. It can keep chemistry moving when everything above is frozen. A planet with no sun could still have a hidden ocean. A planet with no sun could still have storms deep underground. A planet with no sun could still be alive in the only way the universe cares about. Not visible, functional. And if that's true, then the scariest part isn't that one of these planets exists. The scariest part is how many could exist. Because rogue planets aren't rare accidents. They can be created when solar systems form, when giant planets shift, when gravity throws smaller worlds into interstellar space, like debris. That means the galaxy could be filled with wandering worlds we can't easily detect. Millions, possibly billions. And if even a small fraction of them can hold heat under ice, then there could be more ocean worlds in darkness than there are planets in sunlight. So, in the next part, we're going to break down what could realistically keep a sunless planet warm, what scientists look for when they try to detect these invisible worlds, and why the most unsettling possibility is not that they drift alone, but that some of them might be traveling with something hidden. Because if a planet can survive without a star, then it doesn't need a home. It becomes the home. The first reason a planet without a sun can still be warm is simple, and most people forget it. Planets are born hot. When a planet forms, it's built from violent collisions. Rock slams into rock, material compresses. Gravity squeezes everything tighter and tighter. That process generates enormous heat. Even Earth still has a hot interior because it hasn't fully cooled down yet. Now, imagine a planet that forms large enough, dense enough, and insulated enough, then gets thrown into interstellar space. It loses sunlight, yes, but it doesn't instantly lose its internal heat. It cools slowly, and slowly in space can mean unimaginably long times. But that's only the first layer. The second layer is the one that keeps the engine running even after the planet should be gone cold: radioactive decay. Some elements naturally break down over time and release heat. On Earth, radioactive decay is one of the reasons the mantle stays active, why the core remains hot, and why geothermal energy exists at all. You don't need a star for that. You just need the right ingredients inside the planet. So if a rogue planet has enough internal radioactive material, it can keep producing heat for millions or billions of years. Still, that heat has to be trapped, and that's the third layer. Insulation. If a planet has a thick atmosphere, even a weak one, it can slow heat loss. If the surface becomes covered in ice, ice can also act like insulation. It sounds backwards, but it's true. A thick shell of ice can protect what's below from losing heat too fast. It can seal warmth in the interior, like a lid on a container. And once that happens, something becomes possible that sounds completely insane for a planet with no sun. A hidden ocean, liquid water beneath ice, in total darkness. Not because the surface is warm, but because the inside refuses to die. At that point, the planet stops being a frozen rock. It becomes a vault, a sealed system where chemistry can keep running. Minerals dissolve in water, compounds form. Energy moves through reactions. Over time, complexity builds, but there's one more mechanism that can turn this from possible into dangerous. A rogue planet might not be drifting alone. It could have a moon, and if it does, gravity can keep the planet active in a way that makes sunlight irrelevant. Tidal heaten dosen tenid. A star. It only needs two bodies pulling on each other. If the orbit between the planet and its moon is slightly imperfect, gravity stretches the planet over and over again. Squeeze. Relax. Squeeze. Relax. That mechanical flexing becomes heat, and heat becomes motion inside the world. It becomes a permanent engine. A planet with a moon could stay active for far longer than a planet without one. And now the story gets uncomfortable, because if that's true, then a planet could be wandering the galaxy in complete darkness, with an ocean beneath ice, warm enough for chemistry, stable enough to last, and isolated enough to evolve in ways we can't predict. No sunlight, no surface, no warning, just a hidden environment sealed inside a world moving through deep space. And that's where the idea of glowing comes back. Because a rogue planet might not glow like a star, but it can glow in infrared. Heat is light in a form we don't see with our eyes. If the planet is warm enough inside, it can radiate faint energy outward. A tiny signature in the darkness, detectable only with the right instruments, under the right conditions. Which means the universe could be filled with warm worlds we can barely see. And when you think about how many solar systems exist, and how chaotic their formation is, the number of rogue planets could be enormous. There may be more planets without stars than there are planets with stars. Not because they're rare, because they're thrown away. That changes everything. It means planet doesn't automatically mean orbit. It means world doesn't automatically mean home. It means the galaxy might be full of silent travelers, carrying sealed environments beneath ice. And there's one final twist that makes this idea even darker. If rogue planets exist in massive numbers, some of them could pass through other solar systems. Some could drift near stars again. Some could cross paths with planets that do have light. And if a rogue world carries an internal ocean, it carries chemistry. It carries potential. It carries systems that have been isolated for millions of years. So the universe isn't just building life-friendly environments in stable, sunny orbits. It might be building them in darkness, then throwing them into space like wandering laboratories. Which leads to the next exception, because there are worlds that don't just survive without a sun, they survive without a stable orbit at all. Planets that swing so far away from their stars that they freeze, then swing back close enough to burn. Again and again, like a heartbeat of violence. In the next video, we are going to look at a planet with an orbit so extreme it shouldn't stay intact, a world that lives through cycles of deep freeze and brutal heating, and somehow remains alive. Because, compared to that planet, a world with no sun might be the calm version of hell.